ado, I'd like to hand you over to Glenn, who is the reason why you came here tonight, not necessarily to listen to me. I've known Glenn for a couple of years now in terms of some of the current project work I'm doing, and Glenn is a guy who's got his fingers in many different pies in different technologies at Bentley Systems. But one of the areas where I've been having quite a lot of debates, discussions, we've been having some challenging discussions, has been around the whole issue about data interoperability around ISO 15926 and trying to get solutions that work. And before I won't go any further than that, I'll just hand over to Glenn, who can then go into a little bit more detail and get a more authoritative view than my view. So over to Glenn.
Thanks, Julian. Good evening, everybody. Basically tonight, Julian asked me to give you a talk on ISO 15926, and we discussed various topics about how we can introduce you to ISO 15926. But basically, I've looked at from the technology perspective and how we can enable the consumer's view of the data. So rather than looking at how you publish it, how can the consumer go and get the information that they want? So I've looked at it more from the technology side. But generally I have a few presentations around business processes side, etc. But they tend to be around the oil and gas. So to try and keep it more generalistic, I've tried to look more at the technology. And then halfway through I've tried to put some questions in to say, you know, if you've got business processes that you'd like to answer, how it can help, and hopefully we can try and address those. Okay, I'm Glenn Worrell, so thanks to Julian and the British Computer Society for hosting me tonight. I work for Bentley Systems, not Bentley Cars. So I'll introduce Bentley Systems, what we do. I'm going to introduce data interoperability in ISO 15926 and a term called IRING, and what that means. IRING is an introduction. I'm going to give a brief history of ISO 15926 and basically the parts that are of interest. So there's many parts to ISO 15926, but I think hopefully from your perspective, part 4, part 7 and part 8. It's like, oh my goodness, but hopefully by the end of tonight you'll know what they mean and how they can be useful and hopefully how you can apply those technologies. That's the aim of tonight. And then I'm going to look at what technologies are available today that have been used and what are the issues with those technologies, and then reach out to you and the people on the internet, etc., to say how can you come up with other solutions, etc., around ISO 15926 as an interoperability standard. So if that's not what you want to see tonight, I apologise. So before I start with 15926, let's think about why Bentley's interested in ISO 15926. So really, we're interested in working smarter together. We have a lot of technologies. And in fact, for those people who know Bentley, they might know us as a MicroStation or a CAD engine, but in reality, we're a very acquisitive company. We purchase a lot of technologies and we have to make those work together. And most of those technologies, indeed nearly all of the technologies, are around about how to sustain infrastructure. We work with infrastructure professionals in helping the design, helping them be constructed more innovatively, and how we can move into operations and make them more intelligent infrastructure. And we're going to discuss that phrase, intelligent infrastructure. But basically, software for design, construction and operations, that's what we're about. And what do we mean by infrastructure? Well, basically, any type of infrastructure. We have technologies which help us design stadiums. We did a lot of work around the London Olympics and the stadiums from that perspective. We're doing a lot of work around the London infrastructure today, and Crossrail and the station design and tunnel design, etc. But globally, we're working on some of the largest projects in the world around oil and gas, around mining, etc. We've just acquired a company who looking at now how we can look at beyond maintenance, etc., looking at reliability-centered maintenance, and all of those have the same requirement of how we can expose that data to the right people and the documents, etc. So we're a privately held company, but basically our technologies are #1 in various industries. #1 with bridges, roads, rail and transport. We do a lot of work for the Highways Agency now with our technologies. Rail and transit networks, do a lot of work with Network Rail. Power plants all around the world. One of the technologies that does expose 15926 data came out of the nuclear industry, Enterprise Bridge. So from that perspective, it's all about auditing change and making sure that change is tracked, etc. We're about $500 million turnover. I think 2012 was very similar as well, which was just announced. So, why do we want intelligent infrastructure? Well, in the last 50 years there's been a large investment in communications and information processing. And now we're starting to see this investment in intelligent infrastructure. So what do we mean by intelligent infrastructure? Well, basically, infrastructure that enables, with technology, enables the consumers to get a greater benefit from it. So basically, power plants with lower emissions. A building which consumes less energy, for instance, and reports on that energy consumption and how it can shut itself down. A roadway designed to handle more capacity, and basically without the flooding, etc., and report on where those water or environment impact is going to be. Basically, something that feeds back and reacts to that feedback. That's what we mean by intelligent infrastructure. And it's our mission to leverage the information technology to improve the design, the construction and the operations of that infrastructure. That's what we're trying to do. And so we need information modeling technology to empower this, to empower the infrastructure professionals, the design teams, the construction teams, etc., move them from that paper construction methodologies and into digital construction methodologies, etc. And then have that feedback from the operations to not only run the asset more intelligently, but actually feed it all the way back to the design professionals to see how that design or that operations can impact, etc. And consider the whole life cycle cost of that asset rather than just the design cost, etc., or the construction cost. So we do that via 3 initiatives: integrated projects with our design technologies, intelligent infrastructures, as we've already seen, and information modeling. And it's the information modeling side which I guess the ISO 15926 part sits in. Okay, so it's how we capture that information and surface the information in many ways to those design professionals, operational people, maintenance people, etc. And that's been our challenge from that perspective. So if we look at information modeling, it can be in many ways. So we've got information modeling for buildings. We all heard of the UK initiative for BIM, Building Information Modeling. But we've got it for utilities, we've got it for power, we've got it for mining. There's many places where the information modeling and the object information model is unique to their practice, etc. Rail tells you that they've got a unique model, etc. They've got linear assets. Highway Agency have linear assets. Oil and gas all have pipelines, etc. So they all think they have something unique. In reality, they've all got a similar set of problems, etc. So from our perspective, we work with many standards, but what we've got a challenge from that perspective is this phrase federation. We don't come at it from a monolithic approach. We don't want the mother of all databases. We can't put everything in because we need this modularization to enable innovation. Okay, we come from an innovative company with CAD, etc. We have generative components. We have technologies which help design the Gherkin, for instance. Okay, so from that perspective, we want to enable innovation. We want this modularization. And as such, as we move, as you see the EPCs move to this federated design teams, and as we see owner operators saying you've got to invest in these local environments, you've got to invest in the Middle East, etc., we see in this federation more and more. We've got to reach out to local construction companies, we've got to reach out to local design teams, small construction companies. And so federation is our way of enabling this. And we need to work with multiple standards. Oh, that didn't work very well, that was supposed to be animated. So basically, there's lots of different standards in there, CDGML, etc. But one of those standards is what we call IRIN. So ISO 15926 Real-Time Interoperable Network Grid. It wasn't my idea, somebody else's, but anyway, it's catchy, right? IRIN. But basically, the way I look at it is, it's ISO 15926 parts 4, 7, and 8. Okay, how to implement it, how to really check that you use it from that perspective. So, what's IRIN? Well, as I've said, it's basically information interoperability to help us identify the standard. It packages it up and basically helps you use it from a part 7, 8, and there is a part 9 which is written, and fundamentally that's just the facades. So from our perspective, it's parts 4, 7, and 8. which builds on the other parts. And again, part 2 is quite complex, but in reality, it's not as important. Okay? From a consumer's perspective and an implementer's perspective, parts 4, 7, and 8 are the real parts where you can start using it today. So, from a simple way to think of it is basically iRing is the FTP of ISO 15926. FTP doesn't mean anything, it's just the standard. You can say, I'm an FTP, well, it doesn't mean anything, I'm an iRing. So basically it's just the standard, and we need technologies to implement it, etc. So, it'd be remiss of me to not mention the iRing user group. So the iRing user group are basically a small community, fairly large community, I guess, depends on your viewpoint, that discuss about the iRing problems, how they've implemented it, etc. I'm going to discuss technologies called iRing tools. But basically, a lot of information, a lot of questions around the iRing technologies, etc. And so, good place to start asking questions. So then, iRing tools is basically an implementation of iRing. Basically, just like an FTP site or an FTP technology. So it's a set of free public domain tools. It's written by the community using BSD 3 license. So totally available, all the source code's available to anybody to go and review and enhance or customize as you see fit. And there is an iRing tool server up there, I'll tell you in a minute. But basically, this is just like FileZilla. It's a public domain technology which is available. So from that perspective, it is just the FileZilla of ISO 15926 and has various clients written around it, etc., that you can work with from that perspective. And there is an iRing sandbox. So just like FTP requires a server somewhere, so iRing requires a server somewhere. It's called the iRing sandbox. It's basically an FTP server where you can go and post your data and you can view other people's data. So just like an FTP server needs somewhere to post a file, for people to pull a file, so the iRing sandbox requires exactly the same. It's a server where people can host their data. And actually, so it does a little bit more. Basically, you can build your own iRing service, but this one's got some database in the back end. But basically, with your own FTP server, you can publish back end data. So I'm going to mention how our technologies are utilized from that perspective. But fundamentally, there are connectors where you can connect it to your back-end database and surface the information using the semantic technologies of ISO 15926. Okay? So, iRing Sandbox is basically an FTP site of ISO 15926. And just before we move on to how we utilize it and what the technologies do, so why is ISO 15926 came from? Well, it's got a very long and complex history. But in reality, the various projects that have been established have come from engineering projects. The Epistle project in the 80s and 90s is the basis for the Part 2 data model. And the various STEP projects, looking at how industry deploys them, is the basis for the Part 4 reference data library, we're going to call it. But it wasn't really until Fiatech took an interest down here with the ADI project that really accelerated it. Okay, it was the accelerated deployment of ISO 15926, and that's really what generated a lot of the interest, took up this development of hosting a Part 4, etc., Part 4 reference data library, looked at how we could use templates rather than just data models, etc., to make the data, ensure the data is compliant, etc. But fundamentally, ISO 15926 now is an ISO standard. Part 2 to Part 8 is published. Part 9 is going through the approval process now, from that perspective. And one of the other parts, actually, you'll hear a lot of talk about geometry. Part 3 is the geometry of ISO 15926. It is published, it's publicly available. And so when people say there's no geometry standard, from that perspective there is, but there is no Part 7 implementation. So Part 7 is how we're going to transfer this information. So there is a geometry special interest group hosted by PostCisa. We have some people working on that. And they have some examples now where they're looking to publish some geometry and some graphical standards. So when you hear that there is no geometry, they're working on it, etc., but it's about how they're represented in part 7, rather than the fact that there is no part 3 from this book. So let's look at ISO 15926. So there's various parts, and as I said earlier, we're interested, or I'm going to discuss parts 4, 7, and 8. And if we think about part 4, that's basically your industry dictionary. This is your dictionary and thesaurus, I guess. And it's part 4 that ultimately enables this viewpoint of tomato, all looking at it from the different perspectives. Okay, so you can actually classify information depending upon what's of interest to you. And I'm going to discuss the reference data library in a little bit more detail. But basically, it is all of the words and the similarities, etc., of how you use those words from your industry's perspective, and how you can build a reference data library based upon the ISO or the JORD. I'm going to discuss JORD in a few minutes as well, the JORD reference data library. So part 4 is the dictionary and the thesaurus and the words that you can use. Well, part 7 basically is the ability to construct sentences. We don't want to transfer words, we want to communicate with sentences. And what part 7 does is says, is that sentence semantically correct? That's what it's going to enable. What is the minimum information to make sure that that communication is valid? Okay? So if part 4 is the words and the similarity of the words, part 7 is the sentences, well, part 8 then becomes that collection of those words. We don't want to talk in sentences from that perspective, we want to talk in whole communication streams, the books, the files. Well, that's the part 8. That's how all that information is collected together and packaged. Okay? So part 4, the reference data, the dictionary, the thesaurus, what words can we communicate with? Part 7, how do we string a sentence together and make sure that it's semantically correct without any missing words? And then part 8 is all those collections of words, etc., in the sentences to make sure that we can communicate in much larger payloads. So let's think about part 4. I said it's the dictionary and the thesaurus. Basically, we might call it the class library or the taxonomy. Okay? And how those are linked together. And here we can see a traditional taxonomy and the information stored in a reference data library. And you could build, if you wanted to, a taxonomy like this. Okay? A car, and a car must be a luxury car, family car, sports car, etc., estate, saloon, from that perspective. Okay? And that would be our viewpoint. And as long as we, I guess, from one perspective, classify this as Glenn's car vehicle taxonomy, I can't be wrong. Okay? Because as long as I classify it as Glenn's, then fundamentally it's Glenn's. Right? This is my viewpoint. And as long as I relate them back to the car from the ISO 15926, or let's call it the JORD reference data library, that would be acceptable as well, as long as I classify it. Well, the structure of the taxonomy in most situations is bespoke. In nearly every instance, you're not going to use the global standard. You might use the global terminology, but in reality, you want to classify it of my car, the cars I sell in my garage. Okay? That's what you want to sort of use. That's how you want to communicate. And so ISO 15926 looks to standardize this reference data library to enable a global viewpoint. And so while a manufacturer might want to create their perspective, we call it a specialization tree, they would want to go in a state, well, I've got a Ford car or a Fiat car or a Ford car saloon. That would very quickly create a very complex tree, which would be very difficult to maintain and very difficult to navigate. And people coming in would then say, I want to see all the Ford cars. Well, how would that work from that perspective? It becomes really complex. So we don't want to use that methodology. Okay, so what 15926 does is uses a process called classification. And basically there's no, I'm going to say no such thing as an object information model. I mean, there can be, but there isn't yet. That's not the primary purpose of the reference data library right now. So basically, it looks at breaking down every property and every value of a property and classifying it from that perspective. And so we have this what's called specialization tree and classification. So what we do now is against the family car and the estate car, we would create a relationship. The Fiat car can be classified as an estate car. And then you might have a specific model, etc., which then the manufacturer might maintain in their reference data library, etc., which then references back to an estate car, so you can find that information. But I guess the way to consider it is that here, every estate car can be considered as a family car. Okay? Basically, if you wanted an estate car, then the chances are you've got a family. You could have a shooting car, but fundamentally, every estate car, the way this is every estate car is a family car. It can be considered as a family car. But if we classify an estate car with Ford, i.e. Ford can be an estate, then not every Ford car is an estate car, and not every estate car is a Ford. That's what it labels. So within the ISO 15926 dictionary, basically we refer this to as the reference data library. And these are designed to be federated. They're based upon the World Wide Web Consortium standards. Okay? From that perspective, they use triple stores to store this information. And so the 1596 community, Fiat Tech and POSC-CESA funded a project called JORD, the Joint Operational Reference Data Project, to build from the current reference data library and a project called the IIP project, to build this 15926 library. And that's basically, when people call about 15926 reference data library, that's what they talk about, this JORD. And it's available at a JORD endpoint. I think I've got the URL should come up. I can't remember how we about this. But basically, the idea is that there will be the JORD standard, and then people will reference that reference data library. So a catalog manufacturer, like Emerson, will reference the fact of what's an instrument, whether it's an inline instrument, and then put their specific properties and their specific instruments against it with the instance data of the catalogs. And so we see other people like EQ Hub is building off the reference data library, but capturing all of those properties against an object information model for their very specific instance. But if you go to the JORD endpoint and ask for a pump object information model, you won't see that. That is not what they're about. Okay, because what would be correct? Would it be a design object information model? Would it be a construction object information model? Would it be a commissioning? Would it be operations? And so therefore they're more interested in capturing the properties that could be handled over the life cycle of that pump and how to capture that information and reference it, etc. And so it's more down to the project reference data libraries and the operations reference data libraries, I guess, that will build this object information model. So if you were to say, my operational object information model is these properties for this type of pump, then that's what you can see. But the beauty of that is, of course, is that if you want to add a property, then you just add a property. You just put in the new classification, I want to see that property. And over time, you can actually turn off a property by declassifying it from that perspective. So the way that they've built the whole reference data library and this classification actually enables over the whole life cycle of the plant means that your object information model never becomes out of date. It'll happen over the whole life cycle of the asset. And there is relationships, etc., to say, well, actually, this is the functional object from that perspective, i.e. pump P100, but actually here's the serialized version of that pump. And so when that information goes against that pump, we can actually say this is when it started to live, this relationship, this is when this pump became the instance of it, but the instance of the functional pump. But then, over time, obviously we turn that off, or might go into service, or might come out of stores, or might come out of stores, and that's exactly what it's designed to do from that perspective as well, is have this whole life cycle of information, and life cycle of information model, regardless of where you are, whether you're in the design, whether you're in the operations, whether you're in the construction, whether you're in the commissioning, and actually being able to always see your viewpoint. So the other example I always tend to give is blue. So if you, as a designer, say a pump is blue, then that's good enough for you. Generally, you just want to know that it's blue. But actually, the closer you get to the real physical instance, then the more interest you take. So as you come to paint that pump, you don't want to know that it's blue anymore. you want to know the Pantone colour. And then you want to know how to prepare that. So actually, if you're BP, their standard of blue is they want to know, it's no longer viable to say it's blue. What they want to know is it onshore or offshore, indoor, outdoor. And that will determine then the colour blue and how that's going to be prepared. So then you create a template to say blue, but actually I need to know these pieces of information. If you don't give me those pieces of information, then I can't tell you what colour blue it is. It's not trusted. So that's what that enables us as well. So you can capture a little piece of information at the beginning of the project and then have that same piece of information but drill into a much deeper level from that perspective and go to the trusted source as well. Okay, that's what we've got to enable. We always want to go back to the trusted source of that information. So just as we saw with the dictionary, well, what does part 7 enable us? Well, basically, we've got this standard terminology now. And basically, I guess, I'm not quite sure the animations are working on this, it's strange. So what part 7 enables us is the minimum information for a data transaction. And that's what we want to try and do as well. We want to move away from the publisher being responsible for all its data transactions. So all of these times, again, I apologise if there's too many design examples, we go and ask for, can you give us this information? Give me all the sprinklers on the second floor. Well, it's always back to the creator of the data who has to provide that information. It's a cost on him. What we want to be able to do with these semantic technologies is expose that information for the consumer to start asking the question. Imagine if every time you put in a web request that somebody had to go and say, oh, hold on, I'll just build that web page for you. I'll pull that information together. That's not the way the web works. It's the consumers who are doing all the work. We publish once, we consume many times. That's what we've got to do, is be able to split that information up so that the consumers can take their viewpoint of the information. That's what we've got to enable with the 1596 technologies. So basically, what the 1596 standard enables is this concept of templates. And what the template says is, what's the minimum amount of information that should be considered as a payload? So for instance, here we're going to see, actually in the next slide, is what this actually comes to, actually. So it's the next slide that makes it interesting. So we can see that if we have an engine capacity of 2000 cc's, we can understand that information. But a computer and a computer system probably could be developed to understand it. And probably you could read a data stream and say 2000 cc's. When I see that, let's assume that 5 pieces of information ago, I received a registration number, and I'll make the link together, right? But that's not what we're about. We're about trying to standardize the information. So what a template would say is, we're going to give you some rules for the payload, and we're going to give you some values. So if you see the value 2000 cc's, or if you want an designed engine capacity, then you must give me a possessor. Some car has to have this information. Okay? It could be a model number, but I've said it's going to be a registration number. Okay? And so a registration number could be a manufacturer model number, basically a possessor. So if you don't give me a possessor, then everything's invalid. And then you must give me a property, and actually, generally the property relates back to the reference data library. So it has to be a valid property as well. Designed engine capacity has to be in the reference data library. And then you can give me a value, and that can be a real, it can be an integer. From that perspective, I can define that. It could be a string if I wanted it to be as well. Then it would be represented by. And then you must give me a unit of measure. If you don't give me a unit of measure, then I'm going to classify it as invalid as well. So from that perspective, this is a generalized template. You can have specialized ones which could say, well actually, if it's CCs, then it must be between these values as well. It can't be lower than 500, it can't be more than 8,000, for instance. Those are the type of vehicles that we wanted to check. So from that perspective, then this is the minimum information that makes that 2000 cc's valid. But this is all you have to give me now. I don't have to see everything around it. I don't have to see all of the cars. I have to see these 4 pieces of information, and I will consider that to be a valid payload. Okay, that's what templates enables. So previously we had to give all these big streams, etc., to put it all in context, whereas now we can just say, give me these 4 pieces of information, I will consider that to be valid. So if somebody starts coming along using semantic technologies or Sparkle, says, show me all of the engine capacities issued against NU, for instance, then they can find that information. They don't have to go through lots and lots of information. They can consume the information of interest to them. So one other thing about templates, though, is that actually there is a way of validating the payload. Okay, so generally, in fact, always, sorry, not generally, always, there is a first order logic rule behind it. So here's an example of one. So class of description triple XYZ will expand to that there will always be a class of description X in the RDF, in the reference data library. There has to be a description called X. So whether it's centrifugal pump or whatever, there has to be a description called X. Otherwise, this payload is not valid. That's the first thing. It has to be in the reference data library. So that's what I'm saying about this property of design engine size. It has to be in the reference data library. If it's not in the reference data library, it isn't valid. The second thing is that this description X has a pattern Y. Okay, so when it says XY, then the Y that's the pattern. That is the pattern. It's as simple as that. And then what it's saying is for this description X, it will be represented by the Z from that perspective. So we can go through and then validate, has class of representative, we can look it up from that perspective and see that there's a relationship, and so there has to be those 3 pieces of information, and this is how they're related. But obviously you can create much more complex, like 2000 has to be within, because the engine size has to be within the valid engine size, CC has to be a valid unit of measure, and from that perspective we can then validate the whole payload and all of those pieces of information, and we can expand them. But really I just wanted to say that actually there is a very formal definition of what creates and validates a template, but from your perspective, if you just use generalized templates, you don't have to worry about that at all. And in fact, you can lift them and lower them. So even if you want specialized templates, generally they always come from these generalized templates.
Sorry,
sure.
Do you mind taking a question now?
No, please do.
Because I'm personally just trying to relate that last slide with the previous one. I mean, are all templates triples?
Not quite. So this wouldn't be a triple, obviously, because this would be a possessor, so it would have to have a representation of NU13 OGX, has to be the possessor. Then this would be the representation 2000, and we would say it has to be an integer or a real from that perspective. And then we would say the property, designed engine capacity, has to be in the reference data library, has to have a property of. So no,
so actually this corresponds then with 4 triples.
Correct. Well, yes. You'll see actually I'm going to show you how these come out in the semantic perspective. But generally, everything's represented by a triple. Okay, but the template, you will see each row comes out as a triple. Yeah, so this is class of description triple, so from that perspective. So if we look at the part 8, so here you can see there's 4 references from that perspective. This is what it actually falls out to. And I have some examples of how those are lifted. But here you can see that this is, and it's very difficult to see because of the fact that everything's URIs. Okay, it all goes back. But fundamentally, the EM1 is actually the value. That's the only thing we can see from here. The EM1 is the only value that we can actually really read. It's a string. But this is what part 8 looks like. Or, okay, a version of part 8 looks like, but in now. Okay, so the 1596 community said, well, actually, we've got to be able to read this thing. We've got to be able to transfer information back and forth, and so therefore we'll use RDF XML. Web Intelligent Language. And I don't know whether there's any OWL practitioners in the room, but there is a slight difference between 1596 Part 8 OWL and OWL, because we have to reference classes and instances with in the same file. So, but generally I've had the conversation with quite a few academics and quite a few pragmatists, and they all recognise that this is actually a very good way of doing it, okay? It does mean that there's some issues with some reasoners, but generally this is the way it works, okay? This is a pragmatic way of implementing it. So Here, this was a little owl tool that I wrote, but actually you can see here, A1, and actually it's looking here at the name reference. So this classified identification has an object, and this is the object, so basically it is an area, so it's just a unique reference, basically, that's all it is, just a unique reference. Has an object, so the template classified identification has an object, has an identification type of name reference, so that comes from the RDL. What's interesting here is that there's more than one property reference to this name reference. I just wrote a little identifier to show that if there was a tilde, then the chances are the reference data library had a mistake in it somewhere. Somebody put two properties. And really, value identifier, so it has three rules, has object, has identification type, val identifier, string A1. And so that's basically how that actually equates to that. And everything that's blue is a URL. You can click on that and navigate to somewhere to get more information. Right? So everything in there is a URL that you can navigate. And then if we look at here, this is displaying it as templates. Okay? But actually just by switching it, we can say show me it as an object information model. So actually what this was saying is this viewing thing, wherever you're getting it from, doesn't exist. Whatever you're trying to say here, I don't understand it. I don't trust it. Which is right, it comes from our PID package and we needed a QID, which is unique to us to see whether we generated the information. So we just created a dummy QID that we knew that came from us because it's only us could generate it. But then the name reference, and again I could click on this name reference and navigate to the reference data library and see what the name reference was, who was using it, who subscribed to it. But fundamentally, it's A1. That's it. So it's got a name reference, A1, and description none. That whole, if I go page up again, all of this information basically says that area A1 has no description. That's all it says. Right? Into 3 templates, I guess. That's all it says. Quite heavy payloads. But it basically means I can strip it down. As you said, it's a triple. I can decide about which pieces of those information I want to use, what I want to consume. That's what it comes down to. That's what the semantic web enables. It enables me to consume what I want to consume, rather than the publisher saying what I shall have. So, nearly there. Questions? Yes?
I may have missed it. I didn't do my homework. What is 15926?
ISO 15926 is the, well, they call it the integration standard, interoperability standard for process chemical plants, basically. So it's, I'll give you some history about basically where it came from, out of the part 2, about how these things all relate to each other with relationships, etc. But basically, we're trying to put a semantic web technology around data standards and enable it over the whole life cycle of our data and our assets. Nutshell in a little bit. Does that answer your question?
Sort of, yeah. So part 3, which you skipped over.
Yep.
Geometry.
Geometry graphics, yep.
Is that akin to the OpenGIS standards?
Not quite. It's I can't remember the exact. ISO 10303 parts.
Okay.
41.
Yeah, I know that.
Yeah. That's what it's based on. Okay. Don't know, it's 21 or 42 or something like that. No. I'm sure somebody out there is screaming at me.
In part 3 also correspond to industry foundation classes as well?
No.
No?
No.
Well, I thought you did.
No.
Not on there.
No. It's just geometry lines and things like that from that perspective, not. So they're more industry, so they would be more in part 4 and be referenced there and referenced back and classified. Okay? Any more questions? That wasn't the last one. About the technology. But I wanted to sort of go over the technology before I went into how they're being deployed or any business processes, etc. from that perspective. No? Happy to go on? Okay, so before I just want to ask the questions before I moved into the technologies, and really the next set of slides look at how the industry and the various companies have utilised ISO 50926 and the technologies that are out there for you to go and pick up and have a look at ISO 50926 and how those are used. So, first of all, part 4, the reference data library. Well, basically it's implemented as a standard triple stop. And it's exposed to end users as Sparkle request. So HTTP postcaesar.org endpoint hash, and you can go into there and actually you can pull down this query list, type in a string, pump, and then it builds you your Sparkle query. Yeah? Fairly straightforward actually. And it returns a set of results, which you can see, and then very quickly you can go and modify your Sparkle and pull out information. You can start to relate information. It's much better with instance data rather than reference data library. But I guess from a data management perspective, the reference data library is a very good example of how to use master data management. You could very easily build another reference data library which classified the properties of where they've been used, which projects they've been used, the values that are valid, and have that published or exposed to the consumers to say, this is my object information model and these are the values that are valid this project. It's very good for master data management from that perspective and how you can expose that. So postcaesar and FeedTech have been working on a standard that put up a robust endpoint. This is the new endpoint. This has been funded by the JORD project. Various oil and gas companies, I guess, and EPCs have funded this. But basically when I say robust, if the whole world was to hit it tomorrow, it would probably fail. World, don't do that, please. I assume the world's watching. But there are lots of opportunities for caching technologies. Because this is not, I mean, you know, the way the web's work now, it's cached everywhere, you know, you cache it in local places. And so there's lots of opportunities for caching companies or caching technologies to take this and combine reference data libraries. Take the JORD one, take a customer one or catalog one, and pull that information together and make it available locally. Okay? Now there is only one, I won't say only one because I guess Ireland to a certain extent does cache them, and you know, writing a caching technology is fairly straightforward, but combining them and caching them is not really standardized from that perspective, and then looking at the deltas and the differences, etc. So there is opportunities from that perspective. Okay. So then there's the reference data library editor. I guess there is no reference data library editor, I don't think. Check with Victor, but I don't think you're actually allowed to edit a triple store with this technology. This comes from the .15926 community, which is the Russian community. The Russians are looking to build a nuclear reference data library. So basically this point, you pointed at an endpoint. So here I just pointed at the JORD endpoint, and then shows you the information that's in there. Has creation date, has a creator, has a definition, has an old PCA RDS number, abrasive centrifugal pump, so it's got a description or label. And basically you can expand this. So here's the part 2, class of inanimate physical object. We don't really know that. But from our perspective, there's an abrasive centrifugal pump. And you can actually view the specialization trees. So has a class, has represented, classified identification, etc. So it's very good for navigating it. And actually what we found is that nearly all of the taxonomy viewers are not very good at viewing the reference data library. They tend to get, I don't know whether it's the size, whether it's the amount of relationships, how they're represented. They don't do a good job of it. They don't do a very good job of it at all, actually. I have written a couple of technical papers on how it could be represented and the changes that need to happen. About sliders, about setting your level of interest, etc., which has gone out to about 3 or 4 universities, And they've all tried to come back with oh, this is how we can make it work, and then you point them to the reference data library and say, show me, and then they all go, oh, actually, it's a bit bigger than we thought. But never mind, it's still a challenge. Representing this information in relationships is a fairly big challenge. And I guess one of the things that I always say about the reference data library is you can always find what you're looking for. You can't find what you're not looking for, from that perspective. Because if you know what you're looking for, you can find it. If you know you're looking for a pump, you can find it. If you don't know there's a pump in there, you'll never find it. Right? So if you don't know it's in there, very difficult to navigate. Very difficult. And all of these relationships, etc., and the strength of the relationships, I mean, that's why it's, I guess, kept fairly simplistic now with these relationships, because it would become overly complex. And really those relationships need to be in your own, from your own viewpoint, probably in your own reference data library. So the .15926 editor has been selected as the tool of choice, but in reality it is the only tool. So within the ISO 15926 community, using the .15926 editor. There used to be an iRing Tools reference data library editor, which was actually very good for doing classifications, etc. But they took that capability out, which is maybe so they can always use this. So one of the projects, the IIP project, is about looking at how we can take industry data models they take Bentleys, they take Intergraphs, they take Avivas, and look at the properties that they use and then say, what does that relate to? Does it relate to a document? Does it relate to a line, a valve, etc.? And then what template should we put that against? And actually missed off this, unfortunately, down here this morning. But they wrote a specific tool, the TIP tool, template IP tool, I guess. So, but basically, it's got some links. It's always been updated. It's written by the community. It's quite a simple, effective tool, good for discussion around the properties, etc., and how we classify them, and trying to use the JORD methodology of assigning templates. Because you don't want everybody assigning templates, so there is a very good methodology about how to define your properties, etc. So I wouldn't say just go and create a reference data library tomorrow and put your own stuff in. You know, have a look at the JORD standard and the methodology, and then go and create your own reference data library, put your own properties in and reference them, etc. with templates. But it's quite a simple tool, and they are on about expanding this so you can update the reference data library as well and publish to a reference data library too. But very basic. You can again go to the iRing user group and download it. It's there along with the latest database for you to review. And part 8, iRing Tools. This is probably the largest implementation of ISO 15926. Again, it's open source, as I said, developed by the iRing user group community. In fairness, probably a couple of major leaders in that. It's being used on several commercial projects, but generally there's pushback from potential 15926 users on the fact that it's open source. There's a lot of companies not allowed to use open source. They see it as a risk, and some people it's not allowed within the enterprise standards. Open source is just not allowed. So there is an opportunity there from that perspective. But generally it works very well, and to be fair, from Bentley's perspective, they've actually written adapters to our technologies and actually promoted those from that perspective. But generally you could take probably any database, map it, and expose your information in part 8 very, very easily, very quickly, very effectively. But the problem comes is when there's a version change or you find a problem with it, then you've got to go and get that community or go and download the source code and do the change and then repost it. So, yeah. Would you want to use it on a commercial project without some type of agreement? I'd like to think you would, but in reality, it wouldn't be my project. Then there's Ariva have developed the iRing environment. And apparently air, for those who speak Arabic, is not a good word to say. apparently. So this was announced at the FIATech Technology Showcase March time, I think. Not March, beginning of April maybe. So this is actually quite a very good technology. We actually there was a presentation on the interoperability of interoperability systems. Yeah, it's like writing a plan to make a plan, isn't it? But basically, the Ariba team and Uriware approached Bentley to validate the Air platform against our EB and the Iron Tools platform, which we did. I guess we sort of moved information into EB and then out of EB and iRing and back into Air from that perspective into engineering applications. And this is the most interesting one because this is actually being built upon a very robust semantic technology called Top Quadrant. There was no Top Braid, Top Quadrant. Basically, very easily configurable, can plug in any Sparkle backend database, any triple store, exposes the information through Sparkle from that perspective. Seem to be very robust. They're very adaptive, and now they're looking at what their business opportunities are, I guess is the correct phrase. So quite an interesting development, I think, in the ISO 15996 community from that perspective. It'll be interesting to see where Uriware and Ariba take it from that perspective as well. So, that was interesting. Not quite sure what that was. So finally, what's Bentley doing with ISO 15996? Well, ISO 15996 is at the heart of our open plant solution product range. We started off with a P&ID solution, which was built upon 15926 at the time, I guess, reference data library, and the specialized tree. But as the standard keeps moving, so this product has to keep moving. We're trying to, so now we're using templates. I guess we have the only, and that's a challenge to other people out there to say I'm wrong, the only P&ID package where you can publish to Part 8, out of the box. You just press a button and it publishes it. We have all the references, etc. from our perspective. And if you add a property, we have a class editor where you can go onto the reference data library and do your own mappings from that perspective, add your own templates and add your own properties. So it is always configuration, there's no customization required. So we can publish directly from P&ID to a Part 8 data file. Geometry is not defined in Part 7 yet, so we're working on that. We've got somebody on the geometry special interest group to push that through. And when it comes out, that will be fundamentally put into this as well. And then we have a 3D modeling capability for the model server, isometrics, again, all trying to push the boundary of what's possible with 15996. I guess that's what the open plan technology is trying to do, is push that boundary and see how can we use it from that perspective. And interestingly, Siemens, I don't know if you've seen in a press release, have announced that they're going to try and embed our open plan technologies into their power solution to try and utilize it because of the ISO 15996 standard. I think DuPont also looked at how they could use ISO 15996 and selected our technology as well. So I wouldn't say it's a perfect implementation of ISO 15996, but based upon where the standard was and how we always play catch up, it certainly is the leading edge generally of ISO 15996 deployments, but from oil and gas perspective. So you and ISO 15926, well, how can you use it? How do you want to get involved with it? From the RDL perspective, there's a tip project every Tuesday, but the RDL and tip editor tools are basically sorely missed. You know, we could do something to view it from that perspective, look at what's there, how we can actually edit a reference data library, a Sparkle endpoint from that perspective. There's also an opportunity for triple store caching and consolidation to enable triple stores to be available closer to the consumer. The FIATech and iRing Today websites have some great resources. I try and maintain the ISO 15926 Facebook to let you know what's happening from that perspective. I also have a Bentley community where I try and publish the projects that we're working on and show you what we did well with 15996, what we didn't do so well from 15996 perspective. But basically, just have a dip in and have a look. The thing I always say is, don't be scared about what the experts are doing. Look at how you would utilise it. And I do have a whole different presentation on the 1596 Bentley's community page, which looks at how 1596 can help from the business perspective, rather than I looked at the technology perspective, because I just thought there's probably more technologists than business people. So that's basically what I had to present tonight.
All right, thank you, Glenn. Have we got any questions for Glenn? You happy? Statement on you? Yeah, that's good. Any questions for Glenn?
Oh, you're always looking forward to the drink, I think.
I was wondering where we've got to with, I mean, you made some references to implementation. A couple of years ago I was exposed to the ITER programme, had quite big ambitions for deploying 15926. I was wondering whether you had any. So that's that's the fusion reactor in south of France.
Okay, I don't. From the Areva perspective, they are looking at how they can hand over information. From the and I should know the name of this, but there's basically a large project in Abu Dhabi, I think, or United Arab Emirates, so we say, where they're getting 2 nuclear reactors, and they've stipulated that all the information must be handed over in ISO 15926. So there is, from the nuclear perspective, there is this demand or requirement to actually build the reference data library from the nuclear side, but I don't know about this ITER project. I know the Russians, the Japanese, and the Far East, etc., are all looking at this reference data library and how they do it. And so, actually, it's amazing what the Far East and the Asian community are doing from that perspective. You know, while we might not see, because I'm more involved with the FIATech and the POSC-CESA, it is happening. There is a lot of activity in those areas as well. So every time you go and meet up with them, you catch up from that perspective. But I think I would have heard from the Areva perspective, and I assume it was an Areva, EDF, Areva.
Yeah, it was interesting. We never really got to the bottom of where the driver was coming from. But, I mean, I'm heavily involved in a lot of this, so I understood a lot of your acronyms and so on. Okay. And it is interesting that gradually these pockets of implementation are emerging. Yeah. And you know, people not necessarily who've been involved in development of the standard, and it's also amazing how much time it's taken us to get this far. That's
you can't let it go at the same speed anymore. It has to be faster, much bigger snowball.
Well, that kind of leads into one of the points I've debated with Glenn quite regularly, is that if you think about something like a mobile phone, there's a huge amount of technology in there, but as an end user, you don't need to worry about technology, because all the interfaces, the front-end layers, are set up to make it easy for you. The bit I see that's missing on ISO 15926 at this stage is all that front-end, so that for a business organisation, it doesn't worry about technology, they just want the solution. That's not quite there yet. I mean, what are your thoughts in terms of what might be needed to actually just tip it over from being a good theory, good theoretical approach to being a real mission-ready business solution?
Yeah, so I mean, from our perspective, that's exactly what the open plan does. It hides all of that technology, right? So unless you go to the class editor, you don't want to see 1596, you just draw, and you get a P&ID, and you press a button, and you have a 1596 payload. So that's exactly what we're trying to do. But unfortunately, from the other industry perspective, you know, when it's not a P&ID or a 3D model, then we need this, what's in the reference data library, and how do I classify something to put my business process around it. So I know there's the DOF 1596 editor, but it doesn't have this whole federated reference data library, build me a reference data library, publish. It needs that little business process to wrap around it to say, well, here's my data store, publish my reference data library, because go away and find the properties and do it from that perspective. And the AIR tool actually does that pretty well, actually. So that could be coming. I've seen that work very well, where they just publish. If the property is not in the reference data library, they just create a dynamic reference data library entry, because it's the template where they say, well, it's a string or it's a number. So generally I can do that, and I'll be the trusted store. I will be the trusted source of that information. But generally, if there's properties out there, then they could be the trusted store for that information. So the air technology, I think, is starting to make that bridge, but we've got to see, it's one technology, we need another technology, or we need people to start consuming it in the business process perspective. Absolutely.
Yeah, good. Any more questions?
Yeah, which of the UK universities are the most active in this?
The university that we sort of went up and discussed was Edinburgh. They have a whole semantic department from that perspective, and they were very interested about how we do it. There was one of the best places to go to actually is the semantic, it's called Semantic Days in Norway. They host quite a lot, and there's a lot of universities go from there. So there was a university from Ireland. There's a German professor over in Ireland, Dublin, who was actually quite big on how to use this, the big data, because really that's what this is. This is about exposing information, big data, and trying to get it from that perspective. So there is interest, but really, it's trying to show them what we're doing from that semantic perspective. But I guess nearly every university has got some semantic and big data interest right now. It's just plugging them in and making them realise this is exactly that. It's big data. It's exposing the information in triples and trying to process that information and surface it to consumers. That's what it's all about. Without having huge data stores, but saying this is the information that I'm interested in, and then doing those relationships for what you're interested in.
Okay, well, thanks Glenn. Is there any more questions for Glenn? Oh, okay, well, at that point I'd like to thank Glenn for his presentation and his answering the questions we've posed at him. I've got a small gift on behalf of BCS, so thank you very much, Glenn. Hopefully we'll be able to stop around for a few minutes. There should be some wine, tea, coffee, etc. outside. And we'll carry on a bit more of a chat around this area or anything else that might be of interest to you in a data management type sphere. So thank you for coming along. And like I mentioned before, our next event is on the 20th of June, which is the all-day event on assessing data quality. So join us for a glass of wine, and hopefully we'll see you on the 20th of June.